And there is a system called SCADA, Supervisory Control and Data Acquisition System. This SCADA system is the brain of the whole thing. Runs the entire distribution, and they controlling any point of it and create redundancy. In case one line goes down, instantly the other line will provide the power without, because airport cannot go in dark. You cannot just have an airplane coming and say, oh, wait a minute, I'll go down. You know, you can't land, just take off and go somewhere else. Especially San Diego Airport. For your information, San Diego Airport is the 5th most dangerous airport in the world for pilots to land, and, you know, not to take off, to land. 5th in the world. That's how bad it is. So the airplane is just coming, passing all these, you know, big, large buildings, tall buildings, but drop, and then short, you know, runway. And as soon as they hit the, you know, runway, they slam on the brake. It's a very noisy place. Anyway, this caught the eyes of a IEEE, which is Institute of Electrical and Electronic Engineers, and a lot of other organizations, and especially the utility company. They don't like this, because what I did, I tapped into their pocket. They were planning to make $27 million a year from this airport renovation. Now they end up making only 14 or maybe less. So they're pretty upset. So you can always come up with these things. The smart grid, smart distribution system not only help to have an end user, to have lower cost, lower operating costs because of the automation system, and lower utility costs, because this additional power that it was coming here, now it goes somewhere else. Because before, they were coming there and it was wasted. Again, I don't want to get into the technical part of it, it's going to be bored to death. But I'm not wasting any, not even 1 kilowatt of power. I'm saving tons of it. That reduces greenhouse gas emission to the atmosphere because they don't have to generate that for airport. So I'm helping the environment, I'm helping the client, I'm helping everyone. So if we can model this and we can do this everywhere, that's the whole concept of a sustainable design. Let's just stop the waste. Let's just develop that attitude when you go to hamburger, joint and sell super size. And then we take 1 or 2 bites and the rest of it goes in the trash. There are a lot of hungry people around. Let's feed them. We can do a lot better. We don't need, the state of California doesn't need 15,000 megawatt of extra power. We can do a lot better. We can have enough power here and we can sell it to others if we play it smart. But as long as we're playing with the game that we're playing now, we continue to be at the mercy of somebody else. So this project just wanted to give you that example of how important the concept of a smart grid, smart distribution, distributed generation, and overall sustainable design is. With that, I think it took enough of your time. I hope I didn't bore you to death with all this technical mumbo jumbo. If you have any question, I'll be at your service. And of course, Dr. Toossi has all my information and contact information in case you need. Thank you.
Okay, question from Natasha.
How long did it take to do that? With all the...
This design,
Yeah.
it took me 4 months to come up with an idea. And then what I did, it was actually 5 scenarios that I came up with. Then one of the things that I had to do, I had to do the financial analysis for every option. So I came up with 5 options, and then I did financial analysis, and then I created 6 categories to evaluate each option. And then I scored them from 1 to 5 for each option. This final option got the highest point because it had the least amount of cost, the highest amount of savings, and most importantly for the airport, highest degree of redundancy. That's why we chose that one. But it took me 4 months to come up with that idea, and it took about 2 years to design the whole system. That's a huge campus, so it was very difficult. We had to do it, dig in underground and see what we have, so we can route our conduits and airports. Yes.
Has it already been implemented, or?
It is under construction right now. It's going to be finished by 2006. Going to take some.
Once it is finished, will that airport, will it continue to be as dangerous as it is now?
Well, that has nothing to do with the airport. The operation of the airport is different. Unfortunately, San Diego Airport is located in a very bad spot. It's right in the downtown. And aircrafts, when they landing, they're going to go through downtown, miss all those high-rise buildings, and they just come in. And the funny thing is, right at the ending, part, there's a 6-story building, so they have to miss that one too, and then drop, and then that. So everybody is scared that one of these days they're going to hit one of those top buildings.
Okay, because I thought now that it has its own small energy source, it's never going to fail, the power. So
The power will not fail.
That's not.
But that's not the case. That is an airport operation from the pilot's point of view, not from my point of view.
Oh,
The issue is the sharp drop.
okay.
Yeah. Yes.
So you talked about how it's hard for small businesses to enter the generation market.
Mm-hmm.
I think that one of the reasons for that is the high cost of connecting to the grid. So what would you think about lowering just the cost to connect to the grid, because then people would at least be able to be self-sufficient and sell that?
There is no high cost involved to connecting to the grid. There are the people who own the grid. They don't want you to connect to the grid because it's theirs. They own it. They spend their money in it, and they say, "Who are you? They want to connect to my grid?" That's a problem. That is the one problem. The politics of the game is another problem.
So who owns the grid?
Utility companies who built it 100 years ago, now they have a monopoly on the grid. They own it. And if you want to buy it from them, it's into hundreds of billions of dollars. So nobody has that kind of the cash. So Edison forever going to own that grid. PG&E forever going to own their own grid.
But I mean, on a small scale, could they just, excuse me, could they just make it so that if somebody wanted to just have solar panels but they're producing more power than they needed, they could just have a small connection to the grid just to their house?
Well, you're not going to connect to the grid. You're going to connect to your, if it's for your house, you're going to connect it to your house system. Mm-hmm. And it's a concept called net metering. So net metering is you have a small panel in your house, and you are connected to a utility. And at the end, the utility will say, okay, we sell you this much, and you use that much over your own, some of your power came back to our system, so the net difference, you used to pay $100 a month, now you pay $20. That's the only thing you can do.
They mentioned this is what they do in Europe, basically. Basically, in Europe, a lot of the farms, they have their own, basically, little solar panel or wind turbine, and the government is guaranteeing that no matter how much you produce, you're not going to take it to waste. You're going to pay, let's say, 50 pence, per kilowatt hour, which is pretty high. At the same time, they're selling it to the customer maybe about 15, 20 pence. So a lot of people are becoming a farmer, they're becoming also energy producers, they're making money. They can sell it for 50, they can buy it for 20. So that's a great incentive for them to do that.
But here we don't have it. Here, our government is different. Our government system is different. We can't get in or interfere in a free enterprise business and giving that kind of incentives. In European, those incentive programs make Spain to use 70% of their power to renewable sources, or Germany or France. I mean, it's a mind-boggling right now. France have a largest tidal wave system in the world, 800 megawatt of power through tidal. That's unheard of. But they do this because their government is supporting them and they have an incentive program. You know, enticing all the small businessmen to get into that.
And the sad thing is that many of these technologies in the 1970s, when there was a oil embargo, it was developed actually in California.
Yeah.
Like, for example, the solar, thermal he was mentioning. It's a company called Abucina, for example, in Spain, that is using we used to have this solar 1 and 2, we discussed about that. And then we dropped it because the Southern California is, for them, it was like $1 per kilowatt hour, and they go for the lowest, generation cost. For them is nuclear, for example, or the coal, because according to their charter, they're responsible to the customer, so they have to make it the most profit. And so we dropped the project, and then Spain picked it up, and now they're becoming one of the largest in the world, actually, that they're producing there. And same thing goes with the wind, that China and maybe Germany picked up, and there were a lot of that was in California, but now we're not basically the top player in the field. I really appreciate it. That was very enlightening. And once again, we thank Dr. Hashipur.